So good afternoon, everyone. Thank you for attending, and welcome to the Taming of the IoT Data Tsunami with Professor Mike Stonebraker. My name is Ken Smith. I'm going to be your moderator today. For today's agenda, we're going to do some very quick introductions. Then going to ask Mike to talk a little bit about the state of the IoT market and where we're heading tomorrow. We're going to take a look at some of what's not working in terms of connecting this tsunami of data to traditional data analytics tools. We're going to look at what does work and what can work, and then show you a little bit about Hopara. And we hope you stick to the end because we've got some really exciting use cases that are going to really bring everything to life. So with that, Mike, I'll let you introduce yourself.
Hi, I'm Mike Stonebraker. I'm on the faculty at MIT. I guess my biggest claim to fame is that I won the Turing Award in 2014. I have been interested in information discovery and monitoring for years and years and years. And I started Hopara to give a new paradigm to how to do this.
Thank you. As I mentioned, my name is Ken Smith. I'm a co-founder with Mike. I'm also a career entrepreneur. I've done 7 startups. I am an angel investor and also an environmental steward. And that's how Mike and I met many years ago when he was getting Hopara started. So, Mike, we know this industry is doubling quickly. It's exploding in all different directions in a variety of different industries. Where do you see, from your perspective, where do you see this industry going over the next 10 years or so?
Well, I think the declining cost of sensor technology means that everything of material significance is going to get sensor tagged to just either record its state or location or some other data in real time. So I think this Find My Phone, which we all use to find lost cell phones, it just points the way. And your cell phone is a many $100 item. But I think that that or similar technology will be deployed to track things that get cheaper and cheaper and cheaper. So I think we're looking at basically sensor tagging most everything.
And we hear a lot of talk about how that's going to really help drive the data-driven organization. What does that require? What kind of a viz system do you need to really be an effective data-driven organization?
Well, let's just take a simple example, which is your favorite hospital is going to sensor tag patients, is going to sensor tag personnel, it's going to sensor tag every piece of movable equipment. And so a hospital is going to be hundreds and hundreds of sensors, and you're going to have all kinds of different demands on the database, real-time database that comes with that tagging. You will have people saying, "Where is my stethoscope? Somebody, it walked off. Where is it? Where is the nearest EKG machine? Where is where is the nurse that's supposed to be paying attention to this room? Where is the patient? He's supposed to be in this room." And so we're going to monitor most everything. And the people monitoring are going to be business users, not just data analysts. So the problem is that you need a viz system to support most everybody. Doctors are certainly not going to look at an analytics engine. So you need a viz system, not just an analytics engine. For this new world that's coming.
Well, you talk about these analytics engines. We've looked into this. What is it that these tools don't have that real-time data, scale data really require? What can they not do?
Well, analytics engines are very, and think Tableau, think Spotfire, dot, dot, dot. They're very good at building dashboards with summary data like you see on the top of the screen. And that if all you want is a point in time snapshot of average stuff that's going on, then they're good at that. But the problem is you want to see this in real time. So if something bad happens, you want to be notified. And then when something bad happens, you want to be able to drill down into what exactly is going on. And so you need to be able to move from summary data to individual data easily without a huge amount of programming. So you need to be able to move from the top screen to the bottom screen and have all of this get refreshed in real time. And that current viz systems just don't do that.
This is kind of, you talk a lot about Google Maps on steroids. What do you mean by that?
Sure. So I'm a huge fan of Google Maps. What you can do is in 21 clicks, you can go from a picture of the Earth to a plot map on your street. And there's no user manual required. You have drill down really is a great paradigm to move from big picture to details, and it's accessible to everybody. Now, if you're somebody like Airbnb who just wants to drop vacancies on a map, well, Google Maps allows you to do that. They have plugins that you can put your data on a Google map. But if you want any other display, you want a floor plan, you want a scatter plot, anything else, and Google Maps doesn't do it. So it's single purpose in a world where you want lots and lots of different kinds of displays. So you want a non-programmer tool, meaning one where you can just keep clicking, capable of doing drill down for lots and lots of kinds of data, not just geographic maps.
Well,
So
let's take an example of that. The client that we have, IBBX. Let's take a look at this one, for example. This is a vibration sensor company based in South America. As you begin to describe this one, Mike, I want to jump over to that as a use case because I think it's a great exemplar for what you were just talking about, the Google Maps on steroids.
Well, IBBX builds vibration sensors, among other kinds of sensors, but their main market is vibration sensors. And if you have any kind of a physical machine, chances are you want to put a vibration sensor on it because usually such things vibrate right before they fail. So you want early notice so that you don't take catastrophic failures. You have time to do maintenance. So that's what IBBX does. And their customers are manufacturing organizations. And one of them is, I guess I shouldn't name their name, one of them has 58 factories in Brazil, spread all over the country. And IBBX has a great dashboard, just like the one we saw earlier. It allows you to see the summary data, and it makes predictions about what machines are going to fail using some machine learning technology. But their customer says, I want to see the big picture. I want to be able to look at a map of Brazil and get the overview of how my factories are doing. If a factory is screwed up, I then want to be able to drill into the details of exactly what's going on. And so that's exactly what Hopara does. And the neat thing about IBBX is they are integrating Hopara into their pre-existing dashboard because they realize that a viz tool complements an analytics tool. So I think with a little luck, Ken is now going to show you a demo of this particular application. And on the screen, you're seeing one of their overview slides.
So as you were saying, the bird's eye view, here we are just north of Rio de Janeiro. These are two example industry positions for IBBX. Obviously, you've got a sensor alert going on in industry B, and as Mike said, in 21 clicks, but actually with Hopara, we can make it go a lot faster. I just click on industry B, and now we're looking at the custom floor plan of that particular industry. You see all the various green sensors in different parts. And as you look at the entire picture of the industry, you see that you've got a problem up in this corner here, and you can look into greater detail and see exactly when this sensor started to report a problem, and you can zoom into greater detail and zoom back out again.
So IBBX is really enthusiastic about our partnership with them. Their customers love the ability to do this drill down. They like the IBBX sensors because they're very, very low power, and they like the machine learning predictions to predict when things are going to fail. And with Hopara, they can put this all together into a complete picture.
But this works for many different types of industries, right? So here's an example of a wet lab partner by the name of Elemental Machines. Tell us a little bit about EM and what they're doing with the Hopara system.
Okay, so EM does refrigeration primarily for the biofarm world. And refrigeration is completely necessary because if it goes away, whatever is in the fridge spoils, and that's often a very big ticket item. So they want to monitor their sensors to figure out when there is an imminent temperature problem. And so with lots of sensors, they want to be able to start from the big picture and then zoom into the details of too warm refrigerators.
So just as in the earlier case, here's a broad view. You're looking at 3 different laboratories. Obviously, the one in the northeastern region is doing fine. The one in Texas might have a couple of sensors blowing off, and you've got a red alert system going on here in lab number 3. So we're going to drill into lab 3. As Mike talked about earlier, with our semantic zoom, we have the roll-up capability where you can see only as much data as the human eye and the human brain can process. This also means we fetch less data from the database, so the response time is faster. And you can see that the sensors are blowing off in various parts of the organization. You can just roll over to get a little bit more information about each sensor and what's happening. And in this case, we're looking at something in this quadrant of the building where this happens to be a particular machine. This machine seems to be having some troubles. Maybe this is causing the problem across the entire laboratory. So as you see, this is a 3D model now of a Siemens air conditioning machine. And as we drill in, we see that there are 3 sensors, one here, and there's a red sensor blowing off here. So we can begin to look at the temperature history, drill into further detail, and find out exactly when the temperature started to rise, what time the problem was, when did it end, so we can do some analysis. We can then go back and see whether there's anything going on inside of this machine. We can actually drill down inside and see if there's any temperature activity or sensor activity in here. There is not. So let's go back, and we're going to zoom back out, looking at the entire lab here. One of the other benefits of Hopara is when you are building a system, you can actually click on the various different layers. You can add layers. You can edit the data. It's all a DIY configuration on the left. And if I wanted to edit data, let's say we knew that this particular sensor here needed to move from this location to a different location, we could actually drag and drop that and it not only replaces the image, you can place or unplace that image, it actually moves the sensor location within the factory floor. So we'll unedit that and zoom back out. Mike, anything else you want to talk about with respect to elemental machines?
So I guess these two examples are both cases where there are a lot of sensors. There are monitoring applications like most other IoT applications where you want to be notified if bad things are happening and then be able to drill into the details. So if you have an IoT problem at scale, meaning you have a lot of sensors and you want to be able to do monitoring and drill down, then Hopara is exactly what you want.
Great. And so with that, I'm going to say thank you for your time, Mike. I know you're very busy, and we appreciate everybody for tuning in. If you'd like to learn more, you can contact me directly, ksmith@hopara.io. We're offering a free trial and free sign up. We have some template applications where you can come and take a look and get inspired by how you might be able to design your data into a Hopara visualization. And there's more information, obviously, on our website at hopara.io. So again, I wanted to say thank you, everybody, for your time, and we look forward to hearing from you.